I want to talk about the additions to Java that have happened since Java 8, since they added streams, lambdas, method references, static and default methods and interfaces, and the optional type. I want to look at what they've done since then. Now, the thing is that individually, none of these are terribly dramatic changes. But when you start putting them all together and using them in a coordinated fashion, it really does start to change the way you develop in Java. So I'm going to go through a few of them. Let's JVM by JVM, JRE level versus JRE level. But then as we get toward the end of the hour, I'm going to switch and show you a slightly larger app that combines records with local variable type inference, with sealed interfaces, with pattern matching for switch, all these different things all in one app, but a very simple app. It should still be pretty understandable to most people, depending on your Java background. Should be fine. I will give you here. So first of all, there's my contact information. So I've got, my name's Ken Kousen. There's my email address, homepage, blog, Twitter handle. I'm on Mastodon. And I've got a free weekly newsletter, comes out every Sunday, called Tales from the Jar Side, hosted on Substack, and a companion YouTube channel where I have some interesting Java-related videos as well. Those are the books I've written in the past. In case you're wondering about that QR code, it goes to the YouTube channel, just letting you know. I think I decided to add that to the last slide too, so if you didn't get it or you don't care, you can wait to decide whether you want to do that sort of thing. Now, I do want to point this out. This is the GitHub repository that contains all the code that I'm going to be showing you. If we make any changes during this talk, I will simply commit them to the repo when we're done at the end. So if you can't read that, it's github.com/my last name, Kousen, /Java_latest, LATEST. So that's where all the code's coming from, and you're welcome. It's got, I think, an MIT license on it or something. Use it for whatever helps. Okay. Now, one thing just to be clear about is that the documentation pages, if you're not aware, always has the version number in it. Now, this documentation page is kind of the master page. If I go to, okay, I'm not seeing, because that's right, I opened it separately. Let me open up a new window here, and I'll make that bigger. So if I go to docs.oracle.com, let's change it to 21, then that will load the documentation for Java 21. If you change that number to any other version of the JVM, it reloads it for that. Now, what I really want is the API documentation. That's the Java docs. But this is, okay. That could have been interesting. This is useful because there's things in here like the JShell user guide. Now, JShell, it's not all that complicated, but there's one set of docs and it's free and it's always there, and it's good to know where it is. There's a few other things in here, but I'm just going to stick with that, and I will open up the Java docs in a separate tab here so that we can look up classes and methods and anything else we want as we go along. Now, I want to say one thing about the licensing mess with Oracle is that things have changed repeatedly. They started in Java 10 requiring a license if you put the Oracle JDK into production, but at the same time, they released it as an open source product. So if you download a build from the Open JDK project, then there's no restriction, there's no fee or anything like that. But if you download the JDK directly from Oracle, then you may wind up having to pay. Usually when you ask them a direct question like, well, what are the requirements for me to stay free? And they say, well, have your lawyer contact. And it's like, all right, we're already there now. There are many vendors that provide open JDK builds. I tend to default to like the Eclipse Adoptium project. Adoptium.net will have a build of OpenJDK that never is encumbered with anything. Azul Systems has one. Amazon has one called Corretto. If you're planning to run a lot on AWS, you could try that. There are many, many vendors that provide it, and they all satisfy the same spec. So you don't have to worry about it in terms of your code, just maybe tinkering around the edges on some of that. Okay, the place to find the basic documentation is at the OpenJDK project under project/JDK. So if I go there, so if I go to openjdk.org, this is the Open JDK project, and I go to the JDK tab here, then this has the release collection for each version of Java. If I said, like, I'll go into 15, for example, then these are the Java enhancement proposals, the JEPs, that were adopted for Java 15. So some of them are in preview, like sealed classes here, but some of them were released, like text blocks. And all you really need to know to get the information is which version of Java to search in, because they don't have a search box or anything like that. But you could also Google it. There's lots of ways to get there. This is your first best resource for any questions you have about an individual feature, because this is coming from the people who wrote the specs, and it's free, so it's directly available. I do recommend taking a look at that, and I'll go over there periodically to look at some of the details. Okay, let's start with Java 9, and they added a really simple feature, and it was collection factory methods. In Java 8, they added static and default methods to interfaces. So interfaces were allowed to have methods that had a body inside it. And you may have noticed that starting around Java 8, the Java developers became very fond of using a method called of as a factory method. It's normally a static method that produces an object. Well, they decided to add of to list and set and map. And then we'll have to talk about of entries as well. So it looks like this, although I'll show it to you in code. You're using the interface list, set, or map, and you call the static method of. With list, then the argument is a vararg list, capital T, ... It's a generic type, and all the values separated by commas. With set, it's the same thing, although I'm deliberately avoiding duplicates for a reason I'll get to in a moment. With map, we've got a problem with the vararg list. They do have up to 20 arguments, which come in pairs, key, comma, value. So key 1, value 1, key 2, value 2, etc. But where do you put a vararg list? And in Java, you can only have one vararg list in a method, and it has to come last. So what are you going to do? You aren't going to put it on the value. So that's when they decided to make of entries, which makes a vararg list of those map.entry inner classes, the entry inner class on map. So how do you create a map.entry? Well, they also added a static method to map called entry. And you add in your key value pairs. If you did a static import of map, then this would just look like of entries with entry, 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 and you could add in as many as you want, and that's very easy to use. So you see, it's not complicated. If I go to my source code here, let me make that a little bit bigger, then I think under collections or test, here is a badly named class called immutable map test. So let me tell you what the restrictions are. There's only a few things you need to know about these. First of all, the collections they produce are unmodifiable. They're not immutable exactly, because if the object you store in it is modifiable, then they seem to be modified, but you can't add, remove, or replace any elements. That's what they mean by unmodifiable. Now, since it still implements the list or set or map interfaces, those methods are still there. Add or remove or put or what have you, but they all throw unsupported operation exception. So that's how they implemented the interface. Isn't that weird? So here's an example where I have a set of string and I just set that of. The other restriction on set is that you can't put in duplicates. If you put in duplicates, it'll throw an illegal argument exception. And if you put in nulls in either list, set, or map, it'll throw a null pointer exception. Those are the only things you have to know. Again, they're unmodifiable, no nulls, no duplicates in set. And that's pretty much it. So this is a set, and this one here is a list. And let me skip down to this one. This is a JUnit 5 assert all that will check all the properties, all the tests that are in here. Each one of these arguments is an executable, and they're all checking assert throws. So if I try to do an add or remove or clear or replace all, any of those operations throw the unsupported operation exception, just to illustrate that. If I try to make a set with duplicates, I get illegal argument exception. If I put in nulls anywhere, again, null pointer exception on all of that. So these all pass, just as a way to illustrate it. Now, this is the one where I use that of entries on a map. What I have here, and I did a static import of the map interface, so I could say of entries with entry, 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 and these are JVM-based languages and their home pages, something simple like that. Now, I also did that down here with the alternating keys and values, and even with the IDE support, that still looks a little ugly, a little awkward. I really much prefer this approach up here with the of entries and the entry, entry, entry. And of course, the one that alternates has a limit on the number of arguments. This is a var list. It's as many as you want. So anyway, that's really all there is to this. I think there was one other thing. No, I think that's good enough. So let's move on to something else. I want to get through a lot of this. Okay, again, no nulls. They produce unmodifiable collections, and you can't put duplicates in set.of, which is different from hash set, right? You can add duplicates to a hash set and it just ignores you, but set.of will not allow that, period. Okay, now, local variable type inference was the big feature in Java 10. And a lot of people got excited about it. I'm like, why? I find that it is far less than meets the eye. Now, for a long time, I didn't use it at all, and I'm starting to use it more and more. Let me show you why and where. Now, I listed this as both JDK 10 and 11 because they introduced it in 10 and then did a slight modification of it in 11. So what is it? It's the var reserve type name. Now, picking the word var was a kind of risky because, of course, all variables in JavaScript are var. And people went, wait a minute, is Java doing dynamic typing now? I mean, is it all determined at runtime? And the answer is no, it's compile time. What they're basically saying is people got tired of all the excess duplication in Java. Employee equals new employee. Why do I have to say employee twice? I already know the right-hand side's a new employee. What else would I be assigning it to? And now you could assign it to var e if you want. But the type must be determined at compile time. Now, it's not a keyword because how many developers over the years have used var as an abbreviation for variable, right? And you're still allowed to do that. So it's a reserved type name, and it's got all these restrictions. You can't use it on an attribute, on a field. You can't declare a type of type var. You cannot use it as a method parameter in an argument of type var. You can't use it on a method return type. Again, all those things have to be known at compile time. It's local variables only. Where is it useful? Well, on for each loops, it could be nice there, and on try with resources blocks. But also, if it's obvious to the most casual observer what the right-hand side is, a new employee or a new project or whatever, then on the left-hand side, you could just say var. It is, in my opinion, the ultimate in passive aggression. It's like people got tired of this duplication and started complaining about it, and the Java team went, fine, you don't like the duplication? Now you can put in var, but only on local variables, not on fields, and not on attributes, and on method parameters, and not on return types. Are you happy now? No, you're never satisfied. Again, this is my impression. I wasn't there. But to give you an idea what this looks like, then I have one called var type test here. Let me start at the top here. Now, again, I put in an attribute, and I had to comment it out because that just gives you an error. Even though I gave it a value on the right-hand side, so we know the left-hand side's a string, you're still not allowed to say that, period. Here, you can do this. You could say var s equals hello world, but what has it bought you? It's like, why not just say string? I spent a lot of time in the Groovy world where they had def, and you're able to say def infers from the right-hand side, and it's a lot like I used to compare it to kids coming from the Java world were like kids coming from a highly restrictive background and going away to college and they're just going nuts. And they used to do static typing everywhere. And now they just say def, 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 def all over the place, And the more experienced people go, yeah, I'll just use def where it helps. And everywhere else, I like knowing what the data type is. Or as Paul King, no, it wasn't Paul King, Dirk Koenig once said, he said, if I know a type and I'm thinking of it, I type it, pun intended, So I mostly use it here. I could go either way on that because on the right-hand side, I know it's a string. And here, this is a lowercase primitive d double. So it doesn't jump to the wrapper class. It really does use the primitive type or the capital D double if you say capital D double. So it figures that out. Now let me skip down a bit. Here, one thing I want to point out to you about var is that the value of var will always be the actual class being instantiated. The data type there is not list, it's array list. Now that doesn't really change anything, right? We know array list, the only methods we're going to use are the methods from list anyway. They're basically the same thing. Array list implements list. But it is worth knowing that the type that's inferred is the type of the instantiated object, the actual type there. So I was able to say, get the class and show it's an array list. And you could do this. And of course, this thing implements linked list, but it's not a linked list because this is one, I'm sorry, this one is not because it's whatever that inner class is that throws the unsupported operation exception when you try to modify it there. Whereas this, I can go ahead and reassign it to anything that implements that and it goes along with it. Okay, now here is where it actually can be useful. See this monster on the left-hand side? Map of question mark extends string comma list of question mark extends integer map equals map.of entries, and there's my entries, and these are strings and these are lists of integer. But look at that. I mean, how does it benefit me to know that level of detail? I could certainly just write var. Especially if all I'm planning to do is get the entry set and print out the key and the value. Why do I need to replace that with the actual explicit type, which suddenly makes this almost unreadable? See? So for each loops, that can be quite useful. And try with resources blocks, you'd have a similar situation like that. Now that was all in Java 10. In Java 11, they said, you know what, we're going to modify this. Now you're no doubt aware that in the for each method on an iterator, it takes a consumer, and on a map, for each takes a by consumer, right? Consumer with two arguments, the key and the value. Well, on a lambda, we generally leave out the data types because they are inferred from the context. We know from the map what they are. Well, the problem with that is you can't add an annotation without a type. If you wanted to put in an annotation like @deprecated or something like that, you have to have a type on the variable. So you could either put in the explicit type in Java 9 or no 10. In Java 11, they said, you know what? You can use var as part of the parameter list on a lambda expression. So it's an edge case. You know, they basically filled in an edge case and said, yeah, we could just say var. Of course, if you say var on one, you have to say var on both. And then you could add your annotation, something like that. So it's rare that it'll come up, but it is legal if you decide you want to do it. Now, this one kind of cracks me up. You have to be able to infer the data type at compile time. So you can't just assign to null. See, if I just try to assign to null, it says cannot infer type variable initializer is null. So it has to know what kind of null, which is a deep existential problem, right? I mean, think about it. And I can say it's a null of type string, even though it's a null of type string. And they go, yeah, okay, you could do that. And I even did this silliness. I made it a null of type void, no less. I mean, the only time I ever use void in a generic type is if I'm doing like a return type on an object and nothing's coming back, but I want to know it's done, something like that. If you've ever used a flux or a mono, you can get back a mono of type void just to say, yeah, we'll let you know it's complete, but there's nothing returned here. But you can use void as a cast. And now I have a var of type, I mean, it's just bizarre. If I said, let's see what it says. Replace var with the explicit type. Yeah, it's of type void, believe it or not. Don't do that. Okay. This one, I had to actually label, don't do this. But I was trying to get as silly as I possibly could. And for us, this is a chance to introduce records as well. So if you've never used records, well, you kind of have a little bit of a treat in front of you. They do have certain restrictions, but just to summarize what records are like, records became generally available in 16. So if you're on Java 17, you got it available. You have everything we talked about so far available. They are immutable data structures. They have getters, even though they don't use the word get in them. So like they would have the variable name in them. They have a primary constructor that's defined outside the curly braces. They auto-generate for you equals and hash code and toString methods. They're kind of a replacement for Lombok at data, except that those are not immutable. So these are immutable. And that's kind of the idea. Now, they actually have some other features, too, that I'll come back to. But I made a record right here. And that's another nice thing I like about records, is records can be nested practically anywhere. Inside other records, right inside a local, inside a method here. You can put them anywhere. What I love records for is for mapping to JSON structures, JavaScript object notation. Because you can just look at the JSON data and script out a record and it looks exactly the same. So it makes it easy for you to play with. You could put it right as a local variable and then make it public and move it out and refactor and all that later if you want to. So I made a record called var with a capital V that has an attribute called var with a lowercase v, nothing in it. So just so I could write this silliness, var equals new var of var. And then, of course, I assert equals that this var string is var.accessor method var. And it works. It all compiles. It's all good. Again, guaranteed to come up on a code review. You know that gag, right? That if you like the other developer, it's paired programming. And if you don't, it's code review, Yeah, the only thing I can't do is I can't make the name of the record a lowercase v var. Again, that'll say, wait a minute, var is a restricted identifier and cannot be used for type declarations. So that was as bizarre as I could get to. But wanted to show you what's possible and what the difference is between a reserved type name and an actual keyword. And by the way, introduce records, which we'll come back to definitely. All right, so I find this one of those things that's kind of less than meets the eye. It's useful, it's fine, it's good to know because a lot of people are going to use it. But I would not use it unless it's immediately obvious to a casual observer what the data type actually is at compile time. So if I'm saying the word new on the right-hand side, I don't mind using var on the left-hand side. If I'm using a factory method that says new buffered reader or something, well, okay, it's a buffered reader, then I don't mind using var. Stuart Marks, who's one of the core team members, wrote a style guide for using this. It's okay, and it still holds up even after all these years. So I put the link in there. When I give the slides to the powers that be, you're welcome to take a look. It's all, again, part of the OpenJDK project. Okay, let's move on. The big thing in Java 11 was an HTTP client. Now, I found that, again, debatable. I mean, it's not bad that suddenly Java has a real HTTP client. It does basically replace the HTTP URL connection, if you've ever used that before. The reason I wondered why they did it, though, is that there's plenty of open source HTTP clients in Java. Apache has a good one. The Kotlin has one. OK HTTP uses one, OKIO, for example. There's a bunch of examples out there. Why put one in the library? And the answer was, I don't know, now we have one, And of course, it's Java, so it's a little verbose. Everything's based on builders. But we have it, and it does everything. It's synchronous and asynchronous. And in fact, let me go directly to an example on this. So in my HTTP client, let me show you the idea here. That's the test. Wait a minute. I want to go to the actual client. So there we are. There's a RESTful web service that's completely free and doesn't collect any data. So it's nice for demos. And it's at opennotify.org, open-notify.org. And in fact, here's what it looks like. Open-notify.org, and yeah, they're going to complain, and I want to say go anyway. Yeah, because this site does not support HTTPS. That's why it's complaining. Okay, and it's open APIs from space. It consumes some data from NASA and renders it as a RESTful web service. And like many publicly available RESTful web services, it only supports GET requests. That's it. So the one I'm going to access is this one, number of people in space. And if you look at that, let me magnify the screen here. Whoop, that's a little much. There's the URL. Notice there's no parameters in it. There's no variables you have to supply. You just go to api.open-notify.org/astros.json. They're even doing the content negotiation right in the URL. And yeah, I know everybody pronounces that JSON. I call it JSON. Otherwise, I mean, I like picturing a guy in a hockey mask and a machete while I'm doing this stuff, you know? I mean, where's the humor otherwise? But your mileage may vary. Anyway, this is the URL, and what you get back is this small self-contained object that has a message which hopefully is success, a number is the number of people in space, and then people is an array of these name craft combinations. And you can almost see the records leaping out at you, you know? For each JSON object, I need a record. So I'm going to need one to hold the whole thing and one to be the name craft combination in there. I actually have a plugin in my browser that will render the response nicely. And you see what it looks like. This is the current response, success, and there's the people. Apparently they're all aboard the ISS, and there are 7 of them. So I want to access this from Java. Okay? So this says I need an HTTP request and an HTTP client. Now, I've done one thing in here that requires Java 21. In Java 11, when HTTP client was introduced, it did not implement auto-closable. So you would just declare a variable and create it with the builder and everything. But in Java 21, now it implements auto-closable, so I'm actually accessing it in a try with resources block to guarantee that it's closed at the end of that. That requires Java 21 to compile. It'll complain otherwise. But it's not hard to extract it if you run it in Java 17. So here's my client, and I'm using a factory method with a really good name, new HTTP client. Okay, got it. And up here, I'm making the request, and again, everything's done with a builder. You specify the URI, and URI is a create method that takes a string and we'll parse the URI out of it. Perfect. And you can specify whatever headers you want. I think it's usually good form to specify an accept header to say what you're expecting to get back. And in this case, I want JSON data back. Now this, I did something that wasn't necessary. All the HTTP verbs are actually methods on the HTTP request, but get is the default. So you don't have to say get. You could leave it out if you want, but you could use post, you could put, delete. I think Java, a later version of Java, might have been 18, added the head method. There's also a method called method where you could just specify as a string what the method is. So it's very flexible. And then, of course, you build it. So there's the request. Here's the client. And there's either a send method or a send async method. Those are your two choices. The send method is synchronous, so it's a blocking request. And it'll just wait. Now, like that RESTful web service I'm accessing is like so many free ones. The site's either up or it's down. You're either going to get a response right away or not at all. So I'm just using the synchronous one here. And the arguments to send, let me modify this and adjust the font size. Okay, so it says sends the given request using the client, blocking if necessary to get it, and then the arguments are the request and what they call a body handler, something to handle the return response. And the one that they include in the library that I use the most is of string. There's also a binary array in case you're getting an image back or something like that. There's of file if you want to save something to a file, for example. So there's, again, factory methods to say what to do with it. I'm just going to get a string back. And then this will return it, and there's a couple of possible exceptions that could get thrown, which I'm just rethrowing as runtime exceptions. And that's it. That's all there is to it. I've used it for years now. I've used it with get, post, sometimes put, delete, all these different options. I've used the body handler. Again, if I just take control space, there's discarding if you know there's nothing coming back. Of string, something with subscribers and publishers, of byte array, again, if you have images coming back, of file, you give it a path of where to save things, and so on. You know, they have all these different options here. Now, this one right here, all I'm doing is returning that response. And if I look at the test case for this particular one, then let me jump down to here. So send the request. Oh, wait a minute. Get response. Yeah, that is the one I want. Okay, so send the request, and then you get back this HTTP response, and I said just of string. I didn't parse it or anything. You can check the status code. You can get the headers that are in the response. You can eventually extract the body, and from the body, then again, you know, here's my assertions. The body should contain the word success in it, and presumably if I run this now, it should be perfectly fine. So is it any better or any worse than any other one? I don't know, but it's not in the library, you know? So you have it available. Now, the problem, again, is that the data that's coming back is actually JSON data, JavaScript object notation, and I'm not bothering to parse it. I'm just returning the string right now. And here's what the output looks like. Now, I turned on my word wrap here. So you can see my status code is at 200. Here's the headers. It looks like there's no toString here, but then they list them all one by one, the content type and the date and the server. And then here's the body with a message of success and so on and so on. So it gets it all back. Now, they still do not have and do not plan to add a JSON parser to the standard library. You have to add your own. You have to build one in. So the one that I've added now, in fact, I have like 3 different parsers in the class path here. I use Google's JSON, I use Jackson's object mapper, and I think I used Moshi as well, which is kind of popular in the Android world for a while. And the key here is whether those parsers understand records. Because again, I want to map everything to records. Because records and JSON go together like this. It's really easy. So this one down here says I want to get a JSON response, and I'm going to actually do the body here. That's just the string, but I want to parse it. And here, let me show you what the response looks like. Remember, this is what the JSON data looks like. See how I wrote it, even nesting it, not because I needed to, I just wanted to map it to the JSON data explicitly so you could see everything in one place. I could then move this outside the Astro response. If I did that, if I said, yeah, let's move that up, and then it would give me a problem and it would say, wait a minute, class assignments public should be declared in a file named assignment.java. You want me to do it? And I'd say, sure, and it would move it in there, you know? And you could, again, refactor it however you like. But you see how if you do a top-down mapping of the JSON data with records, it's really easy to do. So I just put in properties that matched the properties and the attributes that match the properties in the JSON data. And I had to pick a name for my name craft combinations. I just called it assignment. I didn't have a clever name for that, you know? So back over here, you can see that, no, I think it was, yeah, close the other one. I hate when it does that. Astro client, there we are. So what I did is I said, let's parse it and use your favorite JSON library. I just instantiated JSON, said from JSON with the string to the class I'm trying to parse. The first parser that worked with records was Jackson, which was fortunate because that comes with Spring. And now I use it all the time, and it really gets records right away. The last one that I saw that figured out records was JSON. That wasn't until like last summer that it figured out how to parse records. Because again, records are immutable and they don't have default constructors. And a lot of the parsers just want to instantiate the class using reflection with a no argument constructor, then call set, and you can't do that with records. So the parsers had to be rewritten to understand this style. So with that, with the parse JSON and everything, then over here in my test now, I can say, let's just get the JSON response again. And this time you'll see the auto-generated toString method. I think I ran the same one, did I? Let me factor this. Oh, I hit the wrong button. Just a minute. Deserialize to records. There we go. So let me run that. And what you'll see is I print out the response, and that was the whole thing. You see how this looks like an array now? And I've got each property with equals with the value in it. That's the generated toString method inside a record. You can override that if you want something else, but it's built right in. And then once I had that, I used the properties like the number here. There are that many people in space, and then navigate down to the people and say for each, print them out, and you get all that data coming right out. So again, the HTTP client working with a JSON parser, very easy way to access RESTful web services. If you'd rather use a different HTTP client, like if you're working with Spring or something, you have a lot of options there. That's fine, but this is built right into the library. The only other thing to point out about this is the send async method returns a completable future. So instead of getting your response back, I actually get a completable future of type HTTP response of type T, whatever T is. So that is the HTTP response wrapped around the Astro response, but I get a completable future. So I threw a then apply on that. So when it comes back, then do the following, print out the status code and the headers and the body, and that's all I did with it. So again, with this RESTful web service, there's no benefit to going async. It just responds right away, but you can if you want. Okay. Now, let's go back to here. All right, there were a couple of things that were added that are command line based. And to demonstrate this, let me go to, oh yeah, I was downloading the, and it failed. Yeah, of course I did. There's a new LLM model out. Actually, I want to make that smaller. From Microsoft, they released Phi 3, and I was going to play with it. You know, let's make that bigger. How's that font size? Can you see that okay? Not bad? Okay. Let me resize this. I'll go to Documents, Java latest. Okay, now I'm in the root of that project that we just saw. Okay, I have a file in the root, not in source main Java, in the root called helloworld.java. You may have heard of it. Okay, if I print it, you'll see hello world.java. And yeah, it's kind of what you expected it to be. All right. But here's the thing. On day one of learning Java, they say you run Java-C and compile it, and then run Java without the file extension to run it. You can't just say Java hello world.java, except now you can. Single file code execution. But it gets weirder. You ready? That worked. It compiled it and ran it, but didn't save the compiled version. There's no .class file for this. But I also have a file in the same directory called hello.java, and I just violated rule 1, right? Rule 1 is that the name of the class has to match the name of the file, and it doesn't. And I can say java hello.java. I got to put the file extension in, and that worked too. That's allowed as well. And to make it even more interesting, I have a file just called hello, and it's got this shebang notation, the hash bang at the top, pointing to a Java distribution on my disk. And you just have to add the -- source flag with any version above 10, really. And there's my hello world program with a main method. I had to make this thing executable, but then I can go /hello, and look at that. I have made a scripting language in Java. I think I'll call it, oh, I don't know, JavaScript? You know, or not. Long way to go for that gag, right? I mean, that is a lot of work, but it's late in the day. This was put in to make it an easier learning path for beginners. I don't really have a good use case for this, but if you're planning to write a script that did have to integrate with some Java system, this works. This will allow you to do it. Now, is it better than writing a class and compiling it and running something from there? That's up to you. But it's available. And in Java 22, they finally said, okay, we're going to have multiple file source code execution. So I haven't even tried it yet. I know it's out, or it might be a preview, but the single file code execution looks for the first file in the directory, in the first class in the file that's public and has a main method in it, and it runs that. And if you don't have any, then it'll throw an exception, but that's the basic idea. Okay, as long as I'm at the command line, here is Java's version of a REPL, read eval print loop. They call it JShell. And it started up a shell, and you can see I'm on Java 21 at the moment. So I go 1 + 1, and hey, I'm a Java developer. Put it on my resume, you know. You finally have a REPL for Java. I mean, Groovy's had one from the beginning. Kotlin has one. The Scala people use theirs. The Clojure people live on theirs. I think Java got REPL envy. They're like, we want one too. And now they have it. And you can, now you see what happened when I didn't assign the result to a value. So it saved it in a variable called $1. I could say, okay, int x equals $1 times 3 or something. And now I have a variable called x as well. See, I can still use that variable that was created. And notice no semicolon at the end of the line either. It's basically just printing right out. I don't have to make a class, don't have to make a main method, but I have to code line by line, which is a little awkward. But let me put in a method, okay? Void say hello, takes a string name, curly brace, and see, it does realize, hey, there's a continuation there because I did an open curly brace. System.out.println, hello, plus name plus an exclamation point. Now I need a semicolon because I'm in the middle of a method. And then I messed it up because I missed a double quote. And you see you've got up arrow and down arrow to get things back, to get the history, and that works. And now I'll close the brace and hit enter, and now I've got a method called say hello. So if I go say tab, you've got tab completion. And that works really well. And if I hit tab again, it says, oh, there's the signature for the method you just added. Press tab again to see the documentation, which I don't have any. But okay, it would give you the Java docs, or at least the beginnings of the Java docs on it. So you do have tab completion, a little bit helpful. And if I put in Dolly, it says, hello, Dolly. It's so nice to have you back where you belong. Seriously dated gag there. I apologize, you know. If you want to roll your eyes at me and say, hey, boomer, you know, okay, boomer, I have no defense. I understand. So at any rate, this is something that's now available. I don't have a lot of good use cases for it. I mean, it works. It is a quick way to experiment, to try out an API you've never used. In fact, if I put in, let's try some commands like /imports, again, tab completion on that. Those are all the packages that are automatically imported. I don't have to write an import at all, and I get everything from Java IO and math and net and NIO file and all those util stuff and then the sub packages there. You notice what's not there is java.time. But I can just go, oh, let's import java.time.star, and now I can go local date, you know, now equals. And again, I'm just doing tab completion, local date dot tab, and there's all the different possibilities and parens, and there now I got a local date. You know what I mean? You could build this up however you want. The only problem with it is I don't really code line at a time in Java. And there's a handful of other capabilities, but that's kind of enough. The interesting question, of course, is what I like to call the VI question. You know, like I've been a VI user for 3 years, mostly because I can't figure out how to get out. You know, how do you suppose you get out? You know, it's not really obvious. You think, oh, okay, exit. No, quit, no. And then you remember, oh, okay, I put in that slash. Let me hit a tab. And now there's all the commands you could do, one of which, of course, is exit. Okay, so EX tab, and now I'm out. Okay, so that's also available at the command line. If you wind up using it for anything significant, please send me an email. I'd love to know what the use case was. There's one more command line thing I'm going to show you, and then I'm going to kind of skip to the big application, and I'll break down individual pieces inside it rather than going step by step. This is only available in Java 18. So if you're only on 17, you don't have this. But if you're on 21, you do. JWeb server. See? This is what they call a simple web server. And it's right in Java's tools package. And you see what it's doing is it's bound to port, well, 0.0.0, 127.0.0.1. You can change the port number. You can change the directory you're in, but I am bound to 127.0.0.1 port number 8000. And if I went to there, if I said localhost 8000, there's that directory. See, there's the files in that directory, and I could go down into source, test, Java, Kousen IT, records, person test, see like that? And you can see over here, it's just spitting out all the gets. The only things you can do with this are get requests and head requests. That's it. No post, put, or delete, no secure sockets, no HTTPS, no special headers or anything. It is a trivial, built-in, tiny little web server that you could run from the command line. I used it in a training class once where the firewalls they had at this organization were so nasty, there was just no way to get anywhere. So I had to provide a web service that people could access. All I did was serve up some files using JWeb server, you know? But I don't really have a lot of good use cases for this. I just want to let you know it's there. And the only way to get out is good old Control-C, you know? Just kill it. There's no graceful way to exit that. Okay, it's available. All right, now, I told you about JShell, and that's where those docs are, by the way, back on that documentation page. They have all the information there. The single file code execution was added in Java 11. Again, the idea is the first top-level class in the file that has a main method is executed, and you could use the shebang notation to make an actual, quote, script if you want to. I'm going to show you a couple of these, then I'm going to go to the bigger example. They finally made switch statements useful. This was called either the enhanced switch or switch expressions, depending on how you use it, was added in JDK 14. The idea is that now switch returns a value. You don't have to say switch on this, and for this case return this, and for this case return that, and oh, by the way, better put in break, 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 or you're going to fall through. No. They use an arrow. It does not fall through. And whatever you return from the arrow, that's the value of the switch expression. And you could put multiple constants on a line for a particular case statement. You know what? I do have one really simple example I want to show you on that. So let me just show you the example here. This is a little function to determine how many days are in a given month. Now there's a month enum in java.time. I put in the year as an int, and you see how return is to the left of the switch statement? So you put in your enum here, and the other rule is the switch statement must be exhaustive. It looks at the data type. It says, oh, if you put in string, you got to cover them all. In this case, I put in an enum, and as long as I put in every value of the enum, I'm good. But you see, now this is the way I learned it in school. 30 days has September, April, June, and November. See, and there's the 30. Otherwise, all the rest have 31, so there's my default clause, but except for February. Now, I would have written February like this. Year has a method called isLeap, and if it's true, then 29, otherwise 28. But I want to show you this little quirk in the switch statements. Do you see this thing called yield? Yield is used when you're in a block on the right-hand side of the switch statement, and you want to return from the switch, but not from the method. Just exit out of the switch. They decided not to try to use return for that also. They used yield for it. That's the only weird part. And that's why I wrote this as 2 lines, just to give you an excuse to do it that way. Okay? That's actually pretty useful now. It's pretty practical. Okay. Text blocks were added in Java 15. There's your multi-line strings. That's quite useful. There's been some controversy over the notion of doing formatted strings, not just plugging in values, but actually evaluating code inside the string, like you could do in Groovy or Kotlin or what have you. And right now the answer is, yeah, everybody hated it so much we took it back out. That was a preview feature in 20 and 21, and then they finally said, we're not even putting that in 22. Everybody hates us. We don't want to be hated. So we'll see how that goes in the future. But text blocks have been around since 15, and they're quite useful. Multi-line strings. They have one real weird quirk to them. They start with 3 double quotes. I call it triple double, but you must have a carriage return after that. If you put any part of the string on that same line, it doesn't compile. But the data type is still string. They didn't make a new class or anything. It's just a string. But here's the good part. Inside that multi-line string, you could put in single quotes, double quotes, whatever. You don't have to escape anything. So they are great when you want to put in JSON data, or if you want to put in SQL code and just dump it in there. And it looks fine and it works just fine. So that I wind up using a lot more than I expected. Okay, we talked a little bit about records. So let me do the bigger example here, just to give you an idea. And I'm going to go through that RESTful web service again. But this time, I'm going to start with an interface. So this is an interface called Gateway, which is a design pattern that wraps network access. We're just going to access something over the network. So a gateway of type T has a method called getResponse that returns a result. What's a result? This is something new. This is a sealed interface. Now, Java people generally don't have a lot of experience with sealed interfaces. Other languages do. What's a sealed interface? It's an interface that is only allowed to be implemented by certain classes that are listed in a permits clause. A sealed class can only have children listed in a permits clause. So I'm going to say result permits, it's either a success or a failure only. Those are your only choices. And a success is a record that implements result and wraps some data of some generic type, whereas a failure wraps a runtime exception, but implements result. Now, you see, the thing about records is records are final. You cannot extend a record. Also, records implicitly extend java.lang.record. You can't put records in an inheritance hierarchy unless you use interfaces. So here is a sealed interface where I'm saying I can have a result and it'll either be a success or a failure. But now it's exhaustive too. So when we get to the enhanced switch we just talked about, we don't need a default clause because it's either a success or a failure. You know exactly. So here is my Astro gateway again. And in the Astro gateway, there's that URL. And once again, this time I'm going to use Jackson's object mapper rather than using JSON for the parsing. So here, again, I'm putting my HTTP client in the try with resources block because now it implements auto-closable. And then I'll make a new builder for the request that wraps around the URL, set the header, do a get, build it, and call send. And when I get back, I'll print the status code. And notice the return type on this method. It's a result. So either this all worked and I parse the body into an object and wrap it in a success. So I got back what I was looking for, or I catch an exception, wrap it in a runtime exception, and wrap it in a failure. It's either one or the other. It's a result like that, and nice and simple, see? And then I could even go a step beyond that, and here's my Astro service, which says, okay, I'm going to wrap I'm going to wrap a gateway. I'll stick with the interface here. And I mean, this basically would be Spring auto wiring, but I'm doing it manually, plugging in my gateway. And now I'll go get response. And this is probably violating what I said about using var only when it's really obvious what you're getting back. But I needed to squeeze it in there somewhere. And look at the return. Switch on the response. If it's a success, this is called pattern matching. You declare a variable after the type, and if in fact we are of type success, of type Astro response, it will automatically declare the variable of that type and cast it. And you're ready to use it. I'll extract the data, and then I got a method down below to parse it. If it's a failure, I'm just going to rethrow the exception that came out of it. But I don't need a default clause. See how they work together? The sealed interface with the records, with the pattern matching for switch, with the enhanced switch expression there, and even the HTTP client and the var type. You know, if I didn't have, now the only thing here that might be awkward for you when you try it out is that pattern matching for Switch did not become generally available until freaking 21. It was a preview feature in 17 and 18 and 19 and 20, and then released in 21. So I'm running on 21 so I can do all this. Otherwise, it's a giant nested if statement again. Although notice again, the pattern matching is there. But pattern matching for instance of has been there since about 15 or 16. That's the idea. And then here's my extract map, which does a grouping by to say how many astronauts are aboard each ship that happens to be in space. See? And if I go to my test case for this, let me scroll down to the one that uses the real one. So I instantiate the gateway, plug it in the service, get the astro data as a map, and say, okay, let's get that and print out the astronauts. And I'm using assert J to say that the number is positive, and here's the craft, and there's 7 astronauts aboard the ISS, for example. And you see how all the combination together kind of changes your style. In fact, there's some discussions that this is a new style of coding, which I think Brian Getz was calling data-oriented coding. And I'm waiting to see if that catches on. I'm finding it somewhat useful, but you see, you take your records and you map it to all the data structures, and then you use a sealed interface to say, these are the only things I can do with them, and then build the structure around that. And we now have the HTTP client and everything. And it really is a small way of getting a lot of power out of it. Okay, so let me summarize. The thing I didn't get to in the records is that you can have what they call a compact constructor inside the record. And what that means is it's the same as the name of the record, but doesn't have parentheses at all. And you put in your braces, and what that'll allow you to do is to transform the input data or to authenticate the input data. You know, if this is below 0 or something, throw an exception. You can do something like that. I do that in the AI talk tomorrow. I share some of those things like that. So that's a neat little thing too. But there's the basic information about records, which we already talked about. Pattern matching for instance of was 16 for Switch, and for records, record patterns I'm not showing. That allows you to extract the data completely from the record. But there's the pattern matching for instance of, and Brian Getz wrote an article about where this is all headed. And then this is the example from the JEP. I don't really like this example because they're not doing anything that you could do only uniquely with those data types. That's why I like my success or failure example, which, by the way, is not mine. The Kotlin people have been doing that for years. You know, but that's a nice example of a sealed interface. It's either a success or, like if you're doing a website, either the request is completed or in progress or an error. You know, you could do that as a sealed interface as well. There's the sealed classes. I already told you about it. Permits. This again was from the JEP. The child classes here have to either be final or also sealed. See, rectangle as transparent and filled, or, and this one cracks me up, non-sealed. It's the first keyword in Java that has a dash in it. And non-sealed means, yeah, now you can extend that however you want, leaving open the really weird question of why would you make subclasses of square? But all right, maybe they're going with colors or something like that. I have no idea what they're doing. But this is the example directly from the JEP. I did things slightly differently, the success or failure thing. The simple web server I told you about. And, oh, by the way, there's a deprecated annotation now so that you could see when things are going to be removed. In fact, if you go to the Java docs, there is, in fact, I got to make this smaller. There's now a tab at the top that says deprecated. And you could see in what version things were deprecated and whether they are terminally deprecated. You know, sometimes you're going to hear a knock on the door of Sarah Khanna and take out the deprecated. I know my gags are really dated. I apologize, you know. At any rate, this is all right in the Java docs, and they'll even tell you which and when and so on. So that's kind of neat. There's a website called the Java Version Almanac. If you go there, it will show you, you pick a Java version, you pick 2 Java versions, and it shows you what the differences are. What was added between 17 and 21 or between 14 and 16? You could just pick them and they'll show you all the details. So if you happen to be working with a different Java version, you could find out where things were added if you like. That's really nice. The new stuff in 21, there's sequence collections. So the collections all have like an add first and add last, or get first and get last, or remove first and last, or reversed. Those are all available now. And these were retrofitted into our class structure. So collection, there's a sequence collection, and list, the one we've been using for years, now has those extra methods in it. Same thing with the sets and with maps, so it's all been integrated in. If you go into Java 21 and you write .get with parentheses 0, it's going to say, hey, don't you want to do get first? And you're like, okay, but now you're on Java 21. And then the one that got all the press was virtual threads. And that will affect our lives, but only indirectly. Only if you actually do your own thread management. Most of us don't do that. We synchronize shared data structures, but we don't generally make our own threads. But now, let me just skip to the example here. Virtual threads. I got the wrong one. Just a moment. That's the problem with trying to go too fast. There. This is the example from the JEP. In the main method, they use this method called new virtual thread per task executor. And all they're doing is submitting runnables to that executor service. And you see that you could submit 10,000 of these and you don't run out of memory. And in fact, these will all be pretty much concurrent. And if I run this and I run 10,000 of these things, it should take, again, 1 second, a little over a second. So these are nice, and they'll be very useful for people who are building servers for us. I just don't know how much they're going to affect our lives, even though they really did get a lot of press and very interesting. All I'm going to tell you about the module system is don't bother. You do get true encapsulation. You get smaller libraries from like the JLink property. You can order things on the module path. Is that worth changing the fundamental meaning of not just private, but also public? If you're making a library for public consumption, yeah, I could see that. But if you're not, yeah, you don't have to worry about it. I don't use modules very often, but maybe that's me. So if your mileage is different, let me know. And that's everything I wanted to show you. One thing at the end here, just I put in the slides when I give it to you. I saw a presentation last year at this conference by, and I can't remember his name, Nanavedekar or something like that. It was an Indian name. Yeah, that narrows it down, doesn't it? And he did a bunch of performance tests on the difference between Java 8, 11, and 17. And this is his GitHub repository where he has all his slides and performance stuff. I asked him if he didn't mind it if I shared that, and he was more than happy to do so. So if you need to argue or persuade your manager or whatever that it's worth the upgrade, that's got a lot of arguments in it. Very helpful. I did not focus on any of the under the hood stuff. The garbage collectors now are miles better than they were a few versions ago. That's always a good argument. But in general, that's fine. And then again, there's my contact information. And thank you very much for coming.